What makes an algorithm efficient?
Efficiency in algorithms means achieving desired results with minimal resources such as time or memory. Efficient algorithms solve problems quickly and use as few computer resources as possible. Identifying efficiency is important because it helps ensure software runs smoothly and scales well for larger inputs. Let's explore the essential steps to assess if an algorithm is efficient.
Step 1. Analyze time complexity.
Start by examining the algorithm's time complexity, how the number of steps grows as input size increases. Use big O notation to describe it. For example, ON is faster than ON squared for large inputs. Consider the algorithm's best, average, and worst case scenarios to get a complete picture of its performance.
Step 2. Evaluate space complexity.
Look at the algorithm's space complexity, or how much memory it uses relative to the input size. This is also expressed with big O notation. Lower space complexity is generally better, but sometimes more space is necessary for faster results. Balance memory use against speed to ensure practical performance.
Step 3. Consider practical performance.
Theoretical efficiency doesn't always predict real-world performance. Run the algorithm with different input sizes and data types. Measure actual running time and memory usage using profiling tools. Watch for bottlenecks, parts of the code that slow things down. Testing helps verify if the algorithm's efficiency matches its theoretical analysis.
Step 4. Compare with alternatives.
Efficient algorithms are often found by comparing alternatives. Research other methods that solve the same problem. Implement or study them to see if they offer better time or space performance. Sometimes an algorithm that seems efficient in theory can be improved or replaced by a more practical solution.
Final checklist for algorithm efficiency.
To sum up, determine an algorithm's efficiency by analyzing time and space complexity, testing with real inputs, profiling performance, and comparing with other solutions. By following these steps, you'll be able to confidently judge whether any algorithm is suitable for your purpose and optimize your software for the best results.